Okay guys, this is Cheese. I got the battery built, another one. This is my latest one for my scooter. Previously I had 3P 16S battery pack built, which failed in about a month of use because of a poor conductivity in the silver paste epoxy. Turned out that silver paste epoxy that a lot of money that I paid for turned out to be fake. It's not pure, it's not high grade silver, it's junk, which is why it couldn't handle that conductivity, and it lost connection because the color, it turned into yellow, goldish yellow color, and when it burnt, when it degraded, it almost completely lost electrical conductivity, which is why my battery pack failed. Well, so what I did, because I have much trouble with money, I was able to get another 16 cells of new Samsung 40T cells. So I added to my existing 3P. I took them all apart previously, my failed battery pack, and then rebuilt it with extra 16 cells. Turned it into 4P 16S battery pack using nickel strip for 18650 battery cells, which works fine with 21700. It's just only a little bit, the battery is a little bit bigger, but it's fine. And I used one layer of nickel strip for inner part of the battery pack, starting from here, second row, all the way to one before the last column right here. Single layer and double layer on the ends, on the terminal ends, both negative and positive. This is double layer. As you can see here too, here's a positive terminal. You can see there are much more spot welded marks, like rivets, all the way across, all the way here. Because God told me that I need to apply more spot welding, make more contact points that will increase contact area between the two metals when you combine them, so they becomes a solid one, almost solid one piece. There is difference compared to if you just apply, like, I don't know, like 2 or 4 spot weld marks here and here and here and there. It's not enough. You gotta apply more, especially when you're combining metals together for the double layer nickel strip. And this nickel strip is high grade. I had trouble finding it because God told me that most of the nickel strip that are sold on Amazon, for example, are all fake. Even though they say they are 99.9% nickel, it's not. It's fake nickel. God told me, that's no good, that's no good, this is no good, this is no good, that's no good. I had to go through every one of them until God told me this is okay. He says this is still not pure nickel, but pretty close, high grade nickel content, so it is a lot better. So I got that. I got the charging wire. This is for charging wire. I soldered onto it here on the end, and let me show you better picture, better view here. Same with the negative wire, charging wire. I soldered on here, and this here, this is another nickel strip, spot welded onto the end, terminal end of the negative as well as positive. spot welded, like using like rivets. These are spot welded. You see that, how many marks there are? That's what God told me to do. Do it like that. And I checked the voltage. It's solid. It's everything's connected, and it's showing. It was showing at 63 volt. I don't know if you can see it. Right now 64.7 volt. It's charging at 1.15 amp. It was at 62.9 volt when I built it. Let me show you the other end. I mean the other side. Here's the back side, the bottom side. As you can see, pairs all the way across. Positive, negative, all the way. That's the same way, single layer here in inner side, but the last group are double layer. The opposite side of where the positive and negative terminals are located. That's what God told me to do. He says apply 2 layers here and down there, because he says that it does put more stress on the ends. There's higher temperature and much more intense intensity on the ends. So I applied 2 layers there, single layer here. Same with the top side. And they are holding good. This is the method God told me to use. Spot welding to connect the metals. And this, it will go straight to the controller's positive and negative terminal. This is negative, so this will go to the negative terminal of the controller, go directly. I'll be folding this, fold it and screw in, because my controller has a screw for bolt on to connect the wires. I'll be using this. That's what God told me to do it. So he says it is much better do it this way. I was going to use just solder it the same way I do with this, and God told me no, don't do that, and he stopped me by force. He wouldn't let me do it. I tried to solder here for discharge right here. The solder would not stay on. Even though this is nickel, it wouldn't stay on. It just slides off no matter how many times I tried. I couldn't believe it. I was shocked. I said, what the hell? How is this possible? How the hell is this possible? God told me not to do it. He told me don't. He said do it this way, because this maximizes conductivity. If you use, he says, if you use solder, this solder here, it will limit the electrical conductivity, especially the amp, the current. It will not be able to handle current well, and it will overheat, and it will limit the flow of, limit the connectivity of that current, and you will lose a lot of power. That's what he told me. That's the reason why he told me to do that. Not because it's gonna damage the battery or anything. That's what he says. So that's what I did. It's same way with the positive end. Same way. As you can see here, see this? It goes to there. It's bolted on there using spot welding. So yeah, that's where I'm at, and I'm going to test it. Once I fully charge it, I'm going to install it in the scooter and ride, and I will report the result, how it turns out. And I will also have to check and see how, if it's going to be reliable. Alright guys, just wanted to give you an update. Stay tuned. Okay guys, I have great news. It is working. I put the battery together in my scooter and charged up the battery to about 68.6 volt, and I actually went outside and rode it in the traffic along with the cars on the road, and I was keeping up with other cars, no problem. I don't know how fast I was going, anywhere from 30s to over 40 miles per hour, and I was not even full throttle, just cruising speed, cruising level of throttle that I was using. And oh wow, it's much better, much better with the with this setup, with the nickel connection. And here's my setup here. What I told you about the nickel strips bolted on here, spot welded, it's connecting directly to the controller, both positive and negative. This is the negative, that's the positive, and it connects directly to the controller's terminal, positive and negative. I had to fold it, do it carefully. I had to fold it and shape it so that I can connect to it, and without shorting anything. This is the way God wanted me to do with this particular scooter, with this setup. Wow, what a difference. I thought the 4P would not do very well. I would expect a lot. I was expecting a lot of voltage drop, a voltage spike, because there's not enough parallel connections to handle the power. God told me that it is true. It does make difference. If you have too few of parallel connections in the battery pack, it will cause greater power drop, power fluctuation, power spike, dipping down to lower voltage, greater. And if you have a higher number, then it's better off. But it's not as bad as I thought, nowhere near. It's almost as, feels like it almost as good as some cheap Chinese battery pack, Chinese scooter with low-end battery cells. Power drop was pretty small, anywhere around, I think I was losing about, maybe dropping down maybe 5 volt, maybe 5 to 6 volt, maybe less, around, hovers around that level. I was surprised. It did not stall on me, anything, and I was able to go about 40 plus miles per hour just cruising without full throttle. I am surprised. That's basically it. Everything else, the wires is same as before, no change. I connected the charging wire to here for charging. Charging wires, I have a solder connection for that. And here, I don't know if you can see it. Yep, it's working. God told me that this actually will go fast. I asked him, will it go 45 miles per hour? And he says, no, it'll go faster. I said, 50? And he said, no, it will go faster than 50. So I was, I'm excited. Looks like this will work out pretty well. This is my setup for now. I just wanted to share that, and I will provide update if something goes wrong with my battery. But God reassured me. He straight up told me right away. He told me, don't worry, it's not gonna happen this time. It's gonna be fine. The battery will last, because the connection is done right, spot welded, and I did it as he instructed me with these terminal ends. So there's almost no, there's a minimal power loss, transferring power from battery to the controller because of this direct metal connection without going through solder. God told me that solder is bad. If you use solder to connect the wire for discharging, it's gonna create heat very quickly and it's gonna limit power. And if you try to force it by using more powerful controller, it will go a little faster. It will go faster, but it's gonna heat up much more, and it will put a lot of stress on the batteries, and there's a lot of power you will waste, because the heat will turn into waste and not efficient, usable energy. That's what God told me. So it's very efficient, and I get more power out of it at the same time. I wanted to go 2 layers here in the middle part of the battery, and 3 layers on the ends, but I didn't. God told me I could do that, which is even better, but I don't have enough metal. I don't have enough nickel strips, so this all I had. So it works fine. I have a 50 amp controller, so it'll be fine for this application. Alright guys, take care.